So, step 4, loading on a thread. That's kind of like living on a prayer, but not quite. Alright, enough comedy. The user should trust our application, and they're not going to trust our application if we're doing something that completely freezes the view. So what we want to do is load any things, and network operations are long-running applications. No matter how quickly they return, they're applications that will freeze, or they are operations that will freeze the view, and they should be done on a different thread. They should be done somewhere different than the UI thread. So let me talk a little bit more about what that means and what we're going to do. What we're going to do to show the user that something is happening is have a couple different progress views show up. One of them is this dialog here, which will show up when we're loading the home timeline for the first time, because as you've seen, we don't show any progress right now. But we're also going to show some progress in the header of the application, and then in each of the header and footer views of the list whenever we do something with those views. So let's talk a little bit about units of work and what they mean on the UI thread. So let's moving as time goes on in your application. Like your application might not be doing anything, so it's kind of idle. So let's say for like little chunks of time, your application is idle, and each one of these boxes shows that something's happening in your application. So your application's sitting there idle, not doing anything, and then some user interaction happens, and then because of the user interaction, the application redraws the view, and then maybe there's some more user interaction. It clicks on a button or something like that, and then some shorter operation where we do some calculation or something like that. There's no problem. It just fits into the normal flow of things. Then the UI redraws, and then it's idle again. This is kind of like the normal set of operations that your application does. But let's say instead of a short operation, something that can be accomplished pretty quickly, we have something long. So let's say there's some user interaction, like the user kicks off a load, like for instance loading more tweets. Then the application redraws, and then the application starts this long-running operation where it goes and loads the new tweets. It can't do any redrawing during that part, so it can't respond to user interaction. It can't show progress. It can't scroll the list. It can't do anything besides that network operation because it's blocking that thread. The UI thread is what we call it. And then after that operation's done, then it can continue redrawing and finally catches up to wherever the user wanted it to be. But that's a user experience problem right there. It doesn't allow the user to see that something is going on, and they're like, wait, why is my application frozen? Oh, okay, now finally it's back. So what you want to do instead is run that operation in another thread. Threads are ways that modern programming languages allow you to do concurrent units of work. So have some work happening alongside some other work that you want, some important work. And that's handled at a really low level, however that's handled, but all you need to worry about as a programmer is that you can put long-running operations on another thread, and that will run alongside whatever important work the UI is doing, so that you can let the UI continue to update and the user doesn't think the application just froze. So what you want to do instead of what we did before, where we have a long-running operation that we just slam in the middle of the UI thread, you kick off that long-running operation on another thread, and then you're able to show progress or somehow respond to user interaction during that long-running operation. And then when it returns, we handle the results, and then we continue on as if as normal. So let's look at how we do that in our application. So I'm going to open up step 4. Loading with the thread. And everything that happens is going to be happening on the status list activity. So first difference is on line 25, you can see that I've created a handler class. And if you remember from the beginning of the class, I talked about the handler being the class that Android uses to communicate like sort of the jumping off period and the re-entering period when when those threads are kicked off in the background, and then when they complete. The handler is what responds or helps us notify the main thread that work is done. Then we're also going to create on line 31 a progress dialog that allows us to show that something's happening. And then we're also going to do something on line 39, which is new. We're going to call a method that is on activity called request window feature. And we have to call this before we set the content view. And we're going to request that we show a window feature called feature indeterminate progress. And I'm sure you've all seen this. I'll show you it in action in just a second. But you've all seen a little like spinny progress indicator up on the title of any of your Android applications. That's what we're setting up here. I'll show you how that works in just a second. But this tells Android that we want to use one of those guys. Progress indicator up on the title bar. So now what we're going to do, and everything's pretty much the same on resume, we're going to say load timeline if not loaded. But now in load timeline if not loaded, things are a little different. If our list adapter is null, this is how we're going to load the home timeline instead of what we were doing before. First of all, progress dialog, which is the switch back to this view here. This thing that says we're loading tweets with a spinner there. That's a progress dialog, and it's pretty easy to construct here. If you say progress dialog.show, it needs to take a context, and so we can pass along the status list activity this as a context, and then it needs a title and it needs some description text, and so we can load those off of the resources as a string resource, and we'll just have loading title and loading home timeline description. That basically puts this text into place, loading tweets and loading your home timeline. So we're going to kick that progress dialog off right there. But then here's the next interesting part. We're going to create a new thread, an anonymous thread here, and then implement run. This is all kind of standard thread programming stuff. We implement run, which is what is called when the thread starts. Inside the thread is where we're going to call load home timeline. And load home timeline, as you remember, loads everything from Twitter. And then when it's done, we use the handler to post back to the UI thread that we're done. And what you do with a post is you pass along a runnable. So basically what the handler does is it's kind of a queue of things, and each one of those things in the queue is a runnable task. Which is runnable is just a Java interface, a basic Java interface that specifies a method called run. So when you say handler.post and you pass a runnable, it's just going to call run on that guy. And that guy is able to actually exist back on the UI thread. So that's how we tell the UI thread that everything is done. So again, this thread, when we call start on line 66, run is called on the thread, the home timeline is loaded, and then we post a runnable to the handler, which tells our UI thread that everything is done. And in this case, we're going to use this runnable finish loading list tasks. Let's go look at that guy. I hover over him and hit F3, and down at the bottom of the file, you can see that I've defined this runnable as an anonymous runnable. I implemented it right here. It has a method called run, and basically we say finished loading list inside of there. So let's go look at that. Hit F3. Finished loading list. Again, this can exist back on the UI thread, so it can have access to all of the stuff that we've defined here. I do pretty much everything that I used to do. In fact, maybe it'd be useful here to show side by side step 3. Status list activity, load home timeline. So I'm going to step 3 status list activity, load home timeline on line 58 through line 67. I'm going to put it up side by side with line 95 of step 4's status list activity, which is finish loading list. So in the old version, which is on the right, I load everything from Twitter. I set up the adapter, set load more views, set the list adapter to the adapter I created, and then set the selection to 1. And then in finish loading list, which is again called by that runnable that we post back through the handler when the thread is done of loading all the tweets, I'm pretty much doing the same things, except for setting up the adapter. I just pass in the adapter to the list and then set the list view to show the first or the second, because it's zero-based, tweet as the item as the selection, and then I dismiss the progress dialog, so that makes the progress go away. So let me go through that just one more time. In load timeline if not loaded. Let me close this guy. On line 60, create a thread. When that thread is run, it loads the home timeline, and then when that part is done, because this is all sequential here, when load home timeline is done, then I post that runnable back through the handler. Its run is called. Let's go look at that. And that calls finish loading list, which finalizes all that stuff, puts the adapter into place, shuts off the progress dialog, and that allows our application to be responsive. So let's show that, and then I'll kind of walk through the code where I load things through the headers instead. I think I need to go over here to week 2, step 4, and say run as Android application. Look back at the emulator, and this time when the application starts up and we start loading the home timeline, we should see some progress instead of just a blank screen for a little while. So there we go, the thread kicked off, the progress indicator starts, and pretty soon the thread will end, and the thread will post back through the handler that everything's done, and then this method that the runnable that we posted through the handler, finish loading list, will get called, and then we'll set the load more views, set up the headers, set the list adapter, set the selection to 1, and dismiss the progress dialog. So that all happened, and the interface remained responsive instead of showing just a blank screen that the user couldn't interact with. So that's a much better user experience. Let me go through the whole process of clicking a header. I think this should load pretty quickly, so I'm not sure how quick we'll be able to see everything happen, but this time when I click load newer tweets, we'll see progress appear. Let me do that again. We see progress up here in the top left of the header each time. So that's now the user knows something's happening. And then remember, I asked Android for the indeterminate here up here and on create. In status list activity on create, I say request window feature indeterminate progress. That allows us to show, when I click the header up here in the top right, some progress as well. Right there. Okay, so let's look at the code that does that. So again, that is in on list item click on line 85 of status list activity on list item click. Now I say header view showed progress, and that progress will continue to show, because when I say load newer tweets, if I hover over here and hit F3 down on line 102, I guess I'm being redundant here in the code. I need to clean that up. But when I say load newer tweets, I say header view show progress, and then set the progress bar indeterminate visibility to true. That's a method on activity, which will show, as I switch back to the emulator, that shows this progress indicator up in the top right of the title bar. Then, much the same as I did with the initial tweet load, I set up a new thread, implement run, and then I call the get home timeline with the paging, which in the other case I did outside of the thread. In the other case, in the previous code, which I think I just did inside of load newer tweets. I can set these up side by side to show kind of a little bit of progress here. So this is status list activity from step 3. When I go down to load newer tweets, and I stack these up side by side. This is the older one on the right. I say this hide progress for some reason. I said hide progress there, but instead of loading things in a thread, I just do things right here on the main main thread, get the home timeline, append the newer statuses, and set the selection to 1. Whereas here in the newer code on line 105, I create a thread, and then inside the thread's run, I call get home timeline here. And then create. Okay, so then let me close this up because again, to inform the UI thread that we're done, I have to somehow post back through the handler a runnable. So what I'm doing here is a slightly different strategy. I'm creating a new runnable that I define lower on down the chain. I'm calling it a load newer result runnable, and then I post that back to the handler. And so let's look at that really quickly, and then we'll look at loading the older result runnable. So I hit F3 on here, and it shows on line 164, here's this runnable that I defined here. So it's a private class, implements runnable. It has an instance variable which holds the new statuses, the new tweets that got loaded during that load new operation. And then in the constructor, I just pass in those statuses and let them hold them around. Because this is the only way I can send data back. I have to have something to hold the data as it gets posted through the runnable. Because I can't. Here's the rule. I can't do any interaction on the activity from the outside thread that causes an exception, because it doesn't want you implementing. It doesn't want you changing things on the main thread from other threads, because you can get into some hairy concurrency problems there. So all the operations that you do as a result of the thread need to be done by the handler inside of a runnable. So that's what we're doing here. We create a runnable, and this is the guy that can actually pass in some data by calling finish loading newer in this case. And I can kind of compare. The reason I did load newer result as a runnable and load older result as a runnable was because I need to do different things, and so I call a different method for finish loading older result or finish loading newer results. So let's go look at what I do there. On line 173, finish loading results, or finish loading newer, is called by the load newer runnable in its run method. And when I finish loading newer, I pass in some statuses, and again, just like before, I append newer statuses to the adapter, hide the progress on the header view, shut off the title bar progress by calling set progress bar indeterminate visibility to false, and then I set the selection to 1 in the case when I'm loading newer statuses. And then let's look at finish. Oops, not open resource, open method. Finished loading older. In this case, on line 43, when I hit the footer instead of the header, that runnable will call finish loading older, which will just append older statuses to the adapter, hide the progress on the footer view, and then shut off the indeterminate visibility loader up in the title, and I don't need to do anything else there. So that's what's happening here when I go back to the emulator, and this will be a longer running one when I hit the footer to load older tweets. Show progress up in the title bar, and then once that thread is done, I post the runnable through the handler, and it will hold the list of statuses that I got back from Twitter, and then or actually call a method on the status list activity, which is on the main thread with those new statuses, and I can put those into place and shut off the showing progresses. So there I am loading some older tweets. The older tweets come into place, all the progress is shut off, and everything works like the user expects, and the app is responsive, which is the main point. So units of work, again, short operations are fine. Long-running operations, which network operations, no matter how quickly, need to be classified as, need to go in their own thread, and they need to run concurrently with the UI thread. And then in summary, a handler is what makes it possible to coordinate the activity between your background worker threads and the main thread. Again, the rule is you can't do any interaction with the main activity that you run threads off of, except through a runnable that is posted through a handler. So I assume there'll be some questions after that.
Yes.
Any questions?
We'll take one from the audience, in-person audience here first.
Is there any type of limitation to the number of threads that you can run from an app?
So yeah, that threads take up memory. They also, it's not like they're magically being done on some other processor somewhere else. They all are running through the single processor that the application has. They're just some time sharing or whatever that's going on down there deep in the innards. So even if you're putting things off on another thread, and there's a lot of those things that's still going to slow down the application and cause it to be unresponsive. In fact, the whole device to be unresponsive because that processing power is getting taken up. So yeah, there's a limit. I'm not sure what the limit is, but luckily next class we're going to talk about a way to make it easy to do what's called a thread pool, which is where you limit the number of threads that are running at any one time and then recycle those threads as new units of work come in to be done, or stage up units of work to be done at a future point in time. We don't have to do hardly any work to get that to happen, and I will be showing that in the next class. There is an Android class called Async Task, which does all that work for us.
All right. I have a couple of questions about threads also. One is, how do you protect against loading new and old at the same time, or do you not have to worry about it since it's on the UI thread?
Yeah, so you'll notice that I had I think what this person noticed as well is that when I'm loading the initial tweets, you as a user are presented with a dialog box that's kind of modal, so you can't do any interaction with the app. But when I load new or old tweets, I'm not actually stopping the app from working. So I don't know what would happen. I think everything would just happen fine. We could try really quick. I don't know if things would be, well, especially since there's so many pieces of information, or so many items in the list. I don't know if I could scroll down fast enough to try to hit them both while the other ones are running. But I think everything should happen okay. I don't know why it wouldn't. Each one of those runnables will be posted back.
Yeah, I was wondering if you'd have to synchronize the stati variable to prevent them both trying to write to it.
Well, the adapter is dealing with that, with the actual list. And so when you say append older and append newer at the same time, it should be putting them in the right place. Because no matter what, after those threads are done, something is going to be happening in a synchronous fashion with the adapter. So I don't think that would cause any trouble. But yeah, you could try to prove me wrong. See if you can hit them both at the same time and see if there's a problem. But I don't think from a code point of view that there's any problem.
And then somebody asks if Twitter4j is thread safe.
Good question. I don't know. I'll direct you to the documentation at twitterforj.org.
All right. And then we had quite a few people wondering about the pros and cons of threads versus using async task.
Well, good. If you already know about async task, then use async task. I think the pros and cons are async task will I think everything falls on the side of async task. I would always use async task. I just like that way of programming better. For everybody else who doesn't know what I'm talking about, we're going to be going over that in the next class. So if you already do and you're already building an app, go ahead and use async task. It's pretty much it's better in a lot of different ways.
All right. We had a couple of people who asked about the handler. One person wanted to know. Wanted you to quickly review how the thread gets a reference to the handler, and then another person wanted to know if the handler, the threads that are queued, have the right to change whatever data they want in the main thread.
The threads don't, but the runnables do when they come back. I mean, if there's any, like if we were having problems with different calls returning at different times and modifying the status list adapter, we could synchronize something in there, although who knows, that may be synchronized up the chain. I don't know. The runnables are the ones that can change the data. What was the other question? How the threads got access to the handler? Well, the threads, since it's actually, I'm not quite sure of any sort of pedantic rules about these things. But the thread, since it's created here inside the status list activity, has a reference to those variables, so it can use the handler reference that's already on the activity, which we set up here on line 25.
Okay. All right. And then Sarah has a question from GoToWebinar.
Yeah, from Jim in GoToWebinar. He asks, do all of the new Java concurrency classes work on Android?
I don't know what new concurrency classes. Maybe I'm not up to date with what's new in Java.
We'll see if Jim clarifies that.
Yes. The only ones I know about are like thread pool, runnable, and those are thread pool is made use of by the async task that we've been talking about, so that's definitely usable. I think they're all usable, the ones that I know about. And I don't know when there's any changes to the concurrency libraries. So sorry about that.
So somebody asked, this is Ruth again, hi. Somebody asked, maybe I missed it, or do we deliberately have to get rid of the second thread, or does it go away by itself? I think there's some confusion about when does the second thread complete and when is it gone? Do we have to manage any memory there?
No, you don't have to worry about it. It'll be taken care of whenever so start kicks it off, and then when run is complete, it's eligible for garbage. I think it'll be eligible for garbage collection sometime around there. So you don't have to worry about that kind of stuff. One other class for, I think it was Jim, that I just thought of, is a future task. I think that may actually be new. Future is used by async as well, so that's another concurrency class that gets used and is available in Android.